Any questions before we begin on virtuals and abstract-based classes? Any questions? Okay, as usual, when we start, so first we talked about inheritance and functions in hierarchy and virtual functions are all those good stuff. The next time you came in, we did a review on everything we talked about, but in like less time. Now I'm going to do a quick review on what we talked about again before we continue so we can actually go with an informed brain. So we said that you can have a base class, and the base class that you had can have many different features. Those features are methods that your class has, and those features can be reused by creating a class out of an already existing class. We said we have an animal class, and out of an animal class we created a cat class that had all the features of an animal and had a number of lives. We said that every single function that a derived class has that is identical to the function of the parent overrides or shadows that class, and therefore shadows that function. Therefore, when you call the function of the child of the derived class and it's identical to its parents, it's going to shadow what the parent does. Obviously, if the derived class does not implement some of the methods of the parents, obviously it's going to act like a parent. Number two, we need to understand when we have a derived class, there are not two classes over here. We have one class in belly of another one. So essentially the class is built up of two parts. When I call a cat an animal, it's not a separate object. A cat is an animal, and we have to understand that. The animal features are inside the cat. We said that anything that is in the parent class, in the base class, and is private automatically are not accessible directly to the child. But like any other object, all those features that are private in the base class can be indirectly accessed through using public and protected methods of the class. If we have something in a base class and we are designing the class to actually be a base class and not a standalone class, we can make some of the properties and functionalities of the class, instead of private, protected. By making them protected, we are preventing the outsiders and non-related classes to access them. But if you have a derived class, the protected information are directly accessible to the derived class. So you're literally protecting them. When a feature is protected, it is closed to the public, but accessible to children, but accessible to derived class. Then we talked about each method being called, but that is closer to the reference of how something is called. If I have a cat and call a cat as a cat, all the methods that are closer to cat will be called. So if you have a method that overrides the method of the base, the cats will be called. If I refer to a cat of an animal, all the methods that are closer to an animal will be called, which means the shadowing will not happen because you are looking at a cat as an animal. We can override that feature using virtuality. If we make a method or a function virtual, that closer call to the reference will be ignored, and always the latest version of a method will be called. This virtuality is an ultimate example of polymorphism. When you make something virtual, it doesn't matter how you look at a class, through its base reference or through its own reference, always the latest version will be called. So if you are creating a base class and you require some of the method to be updatable, you have to make them virtual. If there are methods in a base class you don't want them to be updatable, you have to make sure you don't make them virtual. Anything that is virtual guarantees, no matter how you look at the function, how you look at the class, the latest version of the function will be called. Then we talked about the specific type of virtuals, that they are essentially need of a feature to exist in a specific type of class, but the feature is unknown at the moment of design. For example, in this case, sound is one of them. Sound is the one, not the one of them, because you only have one pure virtual method. So in this case, the animal that we have, it has a sound method that is pure virtual. When it's pure virtual, it means I know an animal is supposed to make a sound, but I don't know yet until it is inherited to a more definite type of animal. If it's a cat, I know it's a meow. If it's a dog, I know it's a woof. I can actually do that. But if it's a bird, then I don't know still. So a bird may not implement the sound because still I don't know what type of a bird I have. It's a budgie, it's a pigeon, it's an eagle. I don't know what type of a bird I have. Therefore, I can, if I don't implement the sound, therefore my bird will remain abstract, which gives us the signal. Any class that holds a pure virtual method is designed only to be a base class. It cannot be used by itself. A class that has a virtual method can be a standalone class, which means virtuality is ignored. It's a class by its own. But if it's inherited, the latest version is called. A class that holds a pure virtual method cannot exist. You cannot instantiate it. It's just an idea. It needs to be improved to a type that is completed, therefore it can get instantiated. A cat can be instantiated and referred to as an animal, but an animal on its own cannot get instantiated in this case because sound is incomplete and it's a pure virtual method. These type of classes are called abstract base classes. Is that a question? Yes, go ahead. So let's say the move is not virtual over here, but it's virtual in the, say, cat.
I mean, if move didn't exist in the base class, would it be able to exist in the child?
Of course.
So
of course.
Is it the same if we...
It's not, see, the thing is that if you remove the move from here, it could exist in cat or could not. You had the choice. Right? But if sound is pure virtual, it must exist in a cat. You don't have a choice. Virtuality enforces design. Lack of existence of a method just adds to the features. It could be added or not. We have a car, so a car can be full self-driving, or it could have only autopilot, or it could have nothing. So features can be added to the type of a thing that you have, car that you have. But that doesn't mean that the car, that you have to do it. It's not a pure virtual thing. Pure virtual enforces. Pure virtual is driving. In a car, a pure virtual method is to get to drive the car. A car can be driven. That's pure virtual. If you make a car that cannot drive, what is that? That is not a car, right? So driving is pure virtual, but cruise control being sedan, that's a type. Yeah, let's call it FSD. So a self-driven car, a car that drives itself, then that's like a self-driven car. If it's a type of a car, then full self-driving is optional if you want to have it or not. Yeah, it all depends on your abstraction, which makes it confused. You have a question, right? Okay, so give me 2 seconds, I'll be with you. Okay, just bear with me. The phrase abstraction becomes a little blurry over here. When we started the first half, when I came to the class for the first time, we talked about abstraction, didn't I? Did I talk about it? And I said abstraction is necessary for any language, not object orientation. You need to be able to take what you need to solve the problem and ignore the unrelated stuff so you can do things. If you cannot have an abstract view to something, you can never program because the details become too much. Therefore, you're not going to be able to implement it. Okay? That abstraction is different with this one. They call a class that has a pure virtual method an abstract class because it's essentially created for such purpose, to force you to have a specific type of abstraction in a child, which is having a sound method. It enforces you to look at the child in a specific way, to look at the derived class in a specific way. That's why they call these type of classes abstract-based classes. Yes?
Like in the previous class, you said something about the entire base class.
Mm-hmm.
We can make it all pure virtual, and then it's something.
Oh yeah, we'll talk. That's the topic of today. I'll go through it.
So like that's why I was wondering, like if you're making it all like pure virtual functions, can you make like the constructor?
No, that's not going to have a constructor anymore. You have no action in it. It's not going to get built. Building it is not something. No, because it doesn't have any properties. If you add a property, it's not an interface anymore. So what she's talking about is when we have only pure virtual methods in a class. That's the next thing, the topic of today. So having said all these things, we can come to the next example. We can come to the next example and look at animal as such class that only has pure virtual method. Look at this. This animal is what we call an interface. An interface has no meaning in C++. An interface and an abstract-based class are identical. C++ doesn't care if you have 5,000 things and only one thing is virtual, pure virtual, or they're all pure virtual. They're all abstract-based classes. But in an object-oriented methodology, a class that only has pure virtual method is called an interface. An animal is an interface now. It has no functions. It just enforces each animal to have act, move, and sound. And obviously, we create a pure virtual, we create a virtual destructor that is defaulted. It does nothing. It just guarantees that no memory leak is going to be in future. So this, ladies and gentlemen, is an interface. Okay? That does nothing. And if you look at my code, there is not even an animal.cpp in here. There is no animal.cpp because there is no implementation for an interface. An interface doesn't have anything to implement. Therefore, there is no CPP file. A module for an interface is only a header file. It could have a CPP file, I'll explain soon, but just be aware of that fact.
So would you say that you're just using this abstract for interface as design basis?
Yes! It's pure design. It's just you asking the next programmer to implement the class with this minimum requirements. So you are saying an animal, for anything to be an animal, they should have these features to be called an animal. It's like I create a class and I call it a vehicle, and I would say a vehicle must be driven, must have a brake, must have acceleration, must be able to steer to left and right, and must have a driver. Okay? Or no, we can ignore that one. No. With these cars that drive themselves, so we can ignore that one. But yeah, anyway, so it must be driven, brake, acceleration, and steering around, right? So I'm going to say for anything to be a vehicle, I need these features. Now you can create a truck, you can create a trailer, a tractor, you can create a boat, you can create all these things. So if you have a boat can be driven, it can accelerate, it can stop, and it can steer around. It's still a vehicle. When you make an airplane, an airplane can be driven, which is piloted, can accelerate, can brake and stop, and can steer around. But steering around of an airplane is much more sophisticated. So, but it's still a vehicle. So that's what it is. So to enforce, to say what means to be an animal is to create an interface. That was a beautiful thing that you said that I never mentioned in the other classes. So, all right. Are we good down to this point? All right. But the rest of the story is the same, which means now I have, so what I do in here, I'm going to say now I have a pet. A pet is an animal that has a name. Right? Now this name thingy should, yeah, so this name thingy that I have over here is actually, you know, like when you have a wild cat, it doesn't have a name anyway. When it comes to your house, it's Fluffy, right? So you name your pets. So pet is an animal who has a name. And I can set its name in a protected way, and I can get its name in a protected way, which means the children can set and get the name, but others, you cannot go ask a cat, what's your name, darling? You can't do that, okay? You must have a name tag, an accessor, a function to tell you what the name is. Otherwise, you can't see it, right? So these are the things, and that's protected, so I don't want the cat's name to be known, so I do it this way. Whatever, that's my abstraction of it, okay? That's my view of it, yes. Go ahead.
But it's related to resources that are dynamic.
Okay.
Specifically, char arrays, right?
Okay. Sorry, I want to
If
say.
you want to pass the address, like if you want to return it, pass it, okay? But you want the content to not be changed.
Can you wait until I remember at the beginning of the class I said that what type of a class they gave you when classes with resources were set, and I'm going to give you an example. It's going to address all those. Be patient. Okay? So when I'm going to write that class, that thing that you just mentioned is going to go crystal clear. Okay? So please wait for it. All right? That was the reason that I asked you that question, and I said I'm going to give you an example so I can build up on it when I go for templates. So that's the one. So please be patient on that. Any other question? Suggestion? Yes.
I had a compiler problem that I didn't quite understand
Mm-hmm.
when creating a pure interface class.
Mm-hmm.
And it had to do with the destructor. I didn't have it empty. I just did equal to 0.
Oh, you can't do that.
Yeah,
You have to do equal to default.
Yeah.
The destructor must exist.
Yeah.
Destructor is not destructor is not something that you can say it doesn't exist. It's impossible. So you put the destructor for it.
Yeah.
So that's why I'm saying C++ doesn't understand what is the meaning of an interface.
Yeah.
We refer to it as an interface. If it was Java, you can actually create interface vehicle. You actually call it interface, which means it's everything in it is that you don't need to mention anything is virtual. They're all virtual. So that's how it deals with it. Either you have an interface or you don't. In here, you can have something that is completely pure virtual, which is an interface, or part of it. So that's the syntax for it. You put virtual destructor equal to default instead of equal to 0. You can put empty curly brackets, but that's old style. Don't do it. Equals to default is the best. Equals to default, you're telling the compiler, make the default thing whatever it is. I don't care. So you don't have to have a body for it. Yes. Another question? Are we good? Are we good, everyone? All right. So now pet, and then we go for a cat. And we're going to say cat is a, and then we're going to go for a cat. And we're going to say cat is a pet that has number of lives. And then we continue after that. And we say dog, where is the dog? Oh, we don't have a dog here anyway. So that's that. So that's an interface. We know now what an interface is. There's no big mystery on it. It was very simple, so it takes 5 minutes to explain what it is when you know what a pure virtual method is. Now, let's give you more examples on those things and see exactly how things work out. So in here, I'm going to... So now what I have over here is a kind of more expanded way of the animal kingdom that we have in here. So I have my animal, then I have my pet. A pet can be a goldfish that does stuff like this, but it has a swim too. And I have a pet that is a cat that does all these good stuff. And then I have a bird that does all these stuff, and it has extra stuff. And so as you see, everything is built up on the interface that I have. And it works the exact same way. But what I wanted to tell you is that the bird that we have over here, when you take a look at this bird, sometimes when you create something, you implement everything that you have in an interface. But then you add something that is still pure virtual in here. So if I didn't have the fly in here for the bird, because I didn't know how the bird flies, I just came up with, I don't know, the chicken doesn't fly, just run fast. And so you have to implement them differently. But what I mean is that when you don't know how the bird flies, not a very good example, I make it pure virtual. So as you see, bird is an abstract base class too, although it's inherited twice out of a pet. So you can make something pure virtual halfway through. There's no problem with it. You can still have an abstract base class. Or if I did not implement the sound in the bird, and pet didn't have a sound too, then they will all be abstract still. So if I look at the pet over here, oh, actually, pet is implementing the sound. So pet is not an abstract base class. But anyways, so yeah. So are we good down to this point? Are we okay down to this? So next thing I want to explain is why and how. Let me just look at something in here. Yeah. So how an interface can actually have code. When I say some interfaces, like over here I have animal.h, and in here I have animal.cpp. Well, didn't we just say that interfaces don't have code? They don't have a code by itself, but you might use their imaginary methods and implement something. So for example, I have an animal that can act, move, and make a sound, and they are all pure virtual method. But I can still overload the insertion operator for any type of animal. I can actually use those functions. So in animal.cpp, I am writing the related information about an animal. It's not the animal itself, but about an animal, which means I'm saying an animal is an interface. But if an animal exists, when displayed on a screen, we should mention how they act, move, and make a sound. Although they don't exist, these things don't exist, but I can implement this. What good does it do for me? The good thing is that I do not need to implement this for any of its children if that's what I want to do. If I actually come in here in my main, and I create an array of animal pointers, and I put a cat and a budgie and a goldfish in it, and I'll go in a loop, and I simply say, print the animal. This line is absolute polymorphic line of code because you are saying print the animal. One is going to act like a fish, the other one is going to act like a cat, and the other one's going to act like a budgie. So each one will do its own thing perfectly. Absolute polymorphic way of looking at things. So, and no matter what you do and how you deal with animals, they will just act the way they were designed to. So when I actually run the code, you will see that when it comes to, let me just close this. Oh, it didn't? So when it actually runs, it gets created, everything gets created. But when it actually runs and comes over here, the first one is a cat. It's going to go to the animals print out, but because this animal is a cat, when I say act, the act of cat is called. When it says animal move, because that's a cat, the move of cat and the sound of cat will be called. Then it goes to the next loop, the exact same statement, no difference. Still saying animal, print yourself. It comes on here. Because that animal is a baji, it's going to act like a baji. So each one will get called exactly like that animal with absolutely no difference. Do we understand this? And that's the reason we create codes for the interfaces, to be able to apply certain logic to entire hierarchy of animals in this case. All right? And the other one is just the same thing. I just activated the constructors so it shows the construction of everything. So if I run it, it's the exact same thing. Let me just show it. So just walk through it and see. So the other one is the exact same thing. It just shows that when everything is created, so first the cat is created, so it's a cat and a pet, then a baji and a bird and a pet, and a goldfish and a pet, but no animal, because it is animal, but no constructor is there to do anything. And the rest, we know exactly what it is. And it doesn't matter how you look at your main in here when you look at it. So when you actually, where is it? What was it? Oh, I created a debug class over here to do debugging stuff. So please take a look at it. Just examples of how you can actually do your coding. So for debugging, this is something that I created. Somebody asked the question of how actually we can do the debugging to make everything appear and disappear, like remove the debugging messages. How we do it? I created this thing. It was answered to one of the questions of the students. So what happened is that what I do over here, I simply set one of the ways to actually activate and deactivate an OStream object is to set its buffer to null. So each OStream object, it has a buffer. Anybody knows and doesn't know what a buffer is? You know what a buffer is? Essentially a piece of memory in which you do your work. So like when you are printing something in cout, when you're printing something cout, first it goes to an array, then it gets that array and prints it everywhere. If you set that to null, obviously nothing's going to get printed. That was one of the ways to activate and deactivate. So we know that cerr is another version of cout, right? So I'm going to say when I actually have a debug created, I set the buffer to be the cerr's buffer. To deactivate it, I make the buffer null. To activate it, I set it back to the buffer. So this buffer that you see is actually a pointer to the buffer of cout. If somebody asked the question, and I wrote this, and it remained in here, so I'm explaining to you too. So as you see, the buff is a pointer to a stream buffer. It's of type stream buffer, and when I start, I set the pointer to the buffer of the cerr object. To deactivate it, I make that buffer null. To activate it, I set it back to the buffer. If you don't understand it, just ignore it. It was just somebody was asking a question how to make the debugging stuff activated and deactivated. So like this, you can start printing on C error for your messages. And at any moment when you want to, I'll show it to you. So where is it? Let me just go, for example, in so as you see, it's printing all the messages on C error. If I go to debug and deactivate, then none of these things will actually print for C error, and your debugging messages will not appear. Okay, it's just one way to do it. So it was a question that was asked, and I explained it. So you can completely ignore it and just run it for the constructor messages to appear and disappear. So that's interfaces. So all these things are just all the things that I mentioned over here, just extra stuff. What you need to just understand is if a class has only pure virtual methods, it's called an interface. That's all. All right? Are we good down to this point? All right. Time, 10:37.
you